The last thing I'd like to do is delve just a little bit further into some of the special features of arrays. I don't really need the console anymore over here, so let's close that. Let's go back to the W3 Schools array reference here. Now, we're inside of the for each method, so let's get back to the full reference. And I do highly recommend it. Offers the JavaScript array tutorial as well. Make sure you read through that. That was part of the assigned reading this week, and there's a lot more to it than what I've shown you. Well, let's go down and take a look at one particular function that is wicked useful, and that's sort. Now, depending on what kind of programming class you've had or how far along you are with computer science, you may or may not know about the sorting problem. Regardless, if you're a human being, you've had to sort things before. And that's exactly what this function does. It takes the items that are in the array and it puts them in some sort of order. What's that order going to be? Well, that's up to you. You have to tell it how to order the things. Now, if the things are common, like bananas, oranges, apples, mangoes, these are all strings, well, you can just call fruits.sort and it will sort it. It knows how to sort strings. If they're numbers, it knows how to sort those. Basically, it can sort any primitive value. But the things in there might be more complicated. They might be objects. And sorting objects requires a little bit of effort. So let's take a look at how we might do this, how we can take advantage of this. First, here's the full syntax for this function. You have a particular array and you say .sort. And when you do that, you pass in what's called a compare function. The compare function should compare the two objects. It's going to be given an A and a B, and it should basically return a value based on which one comes first. So if you read this through here, it should return either a negative value, a 0, or a positive value. The negative value means that B comes first, 0 means they're tied, and a positive value means that A comes first. So this is the basic idea. A classic way to do that is, in fact, this little example that they have right here. You just return A minus B. And that would do the job if it was a number. But of course, that doesn't work with all things. I'm going to write a more generic comparison function. So we have down here, add cell to row. Let's also write a function, generic compare A comma B. And here's what we want to do with this generic compare. We're going to ask a couple of questions. If A is greater than B, well, then we should return something. We'll figure that out in a moment. If A is less than B, well, we should return something else. And then finally, if it's not greater than B and it's not less than B, we know for certain they are equal. That's the only possibility left. And in that case, we would return 0. So this is a more generic way to compare things. As long as the things have greater than or less than defined for the object, it should work. The question is, what do we do right here? So if it's greater than, do we return 1 or negative 1? Or do we return a positive or a negative value? And we'll just do 1 or negative 1 for our generic values. And if A is less than B, then do we return a positive or negative? Now I believe what it is negative 1 for the first one and positive 1 for the second one. But let's think about it. They give this example here. We're going to return A minus B. If A is bigger than B, then it actually comes second, right? Because we would sort them in increasing order. So if A is bigger than B and we do A minus B, that means it's going to be a positive value. So when it's positive, A is greater than. And that's not what I did. And when it's negative, B should be the greater one. So let's try that. Again, we can just pick one. Once we get to using it, if we see we're getting our values backwards, we'll go flip it. So I'm writing this right now just as a sort of shorthand that I can use to compare two things in a way that will be handy with the sort function. Now, as I pointed out before, the sort function itself actually works without passing it anything if the stuff you're sorting is just a primitive value. But in our case, it's not. Here's what we want to do. I want to come up here to right below where I extracted my elements for the table and where I start constructing the table itself. All of that happens right here. Let's make this an actual function. I'm going to call it rebuild table. All I need to go down to here. Our other functions, add cell to row and generic compare, are going to be their own things. So here's rebuild table. What I want this to do is to clear the table and rebuild it. Right now, it builds it just fine. It goes through, it adds the header row, puts the data in it, and then it adds all the body rows and puts the data in those. So I just need to do one little extra thing in order to make it actually clear the table first. Now, why do we want to clear the table? Well, we're going to be calling this more than once, and if we didn't clear the table first, it would just keep adding on to the bottom of the table. We'd get a really big table real quick. So instead, let's go ahead and delete all the rows. Now that's not too hard to do. Come on. Clear table. There we go. No, just the table. There we go. So table has a property called rows, and it's an array that contains all the rows in the entire table, including the head, the body, and the foot. And so I can just test that. I can say while, that's a type of loop, my table.rows.length is greater than 0. What does this say? It says, while there are rows in this table, keep doing this. What are we going to do? We're going to delete a row. This is the only function we have available to us. It's the opposite of insert row, of course, and it's going to delete a row, and it will delete it at the place we tell it to. In our case, we'll just say delete it from the end. -1, just like it before, means the end. And so as long as my table.rows has more than 0 rows, it will just keep deleting them. It will delete them whether they're in the body or the head. It doesn't matter. And so this is a real handy way to just clear everything out of that table real quickly. Now the last thing we need to do, up here in the global scope, after we've gotten all these things, we want to build the table for the first time. And so that's going to involve rebuild table being called. We just call it once, and that's why I'm putting the parentheses on the end. So we save this, and there we go. We don't see any changes here. It's still the same thing, but you get the idea. Now, let's do some sorting. What if I'd like to sort this by, well, how about type? I want to see all the types grouped together, so we'll sort it by type. Well, the trick here is that I have an array, and I can sort it if I want to. I could say .sort. But if I just do that, I haven't told it what to sort by. Let's look what's in pets. Pet data here says that pets contains objects, and those objects have 3 things: name, type, and age. Somehow, I've got to make sure that pets.sort is actually going to compare what I want it to. Let's remind ourselves exactly what we give to sort when we need to do a custom sorting. So we have this function, compare function. It's going to receive A and B, and it needs to return either positive, negative, or 0. Let's go ahead and start writing that. So it's a function that's going to receive A and B, and it needs to go through and return, oh, excuse me, I need one or the other. Let's do the inline syntax here. It needs to go through and return basically positive, negative, or 0. Well, one thing we could do real quick, if we wanted to sort by age, that's easy. We can just say return A.age minus B.age. Age is a number, right? So that should just work. We just do A.age minus B.age, and then that should sort it before it builds it. So take a look at what it is now, and let's see what happens now when I save the file. It worked. 7, 10, 15, 20, 30. Wow, these animals are kind of old, aren't they? I think these numbers are maybe not quite right, but that's okay. We've got snakes and other, I think these are their maximum lifespans that I put in there. I meant it to be a little more random than that, but that's okay. You get the idea. So there we go. We gave it a comparison function, the exact same function that it shows right here, by the way, and it sorted it from bottom to top. All we had to do was tell it to use A.age and B.age rather than just A and B, because it doesn't know how to subtract a pet from another pet. Let's go a little further here. I could do A.name. Well, let's do type. Like I said before, it'd be nice to see them all grouped by type. A.type and B.type. Let's try that. Well, that doesn't seem right. It's definitely doing something here, but it's kind of funky. Yeah. So what's really going on here? Well, ultimately, a.type minus b.type doesn't work for strings. You can't subtract strings. Let's take a look at our console here real quick and see if it actually got upset about that. Well, it didn't really. It did it, but it certainly didn't work. This is where our generic compare is going to be more useful than just subtracting them. Let's do that instead. Let's say generic compare a.type comma b.type. Again, here I'm going to use a function. And what that's going to do is going to take type, and it's going to use greater than and less than rather than subtraction. Greater than and less than are defined for all primitive types. So as long as what we're comparing is a primitive type, it'll work. So let's go ahead and save it and see how that does. And there we go. Not only are they grouped together, they're sorted in alphabetical order. So there's all our birds, all our bunnies, cat, chinchilla, dog, ferret, fish, lizard, other, and snake. So now, any particular values I want to put in here, including name, can be sorted. I just need to return whatever generic compare returns. So notice there's a couple of returns in here. That's the basic pattern. Now it should be sorted by name. Alpha, Arista, Arrow, Astro, these are pretty good names. I just got these randomly off the internet. So there we go. This gives us a nice, pretty easy way to be able to sort these things. The last thing I'd like to do is to put this in the hands of the user, the person who's actually working with this page. I'd like them to be able to sort the data. I've done a lot of things leading up until now to make sure that that's going to be easy. So make sure that you've got everything working up to this point. This is the final piece of the puzzle. Let's give ourselves one last function. I'm going to call it sort table. Well, actually, I'm going to call it sort and rebuild table. I'm going to give to this an index that is the particular column we want to sort by. So I'll call it call index for column index. I mean, spell function right there. There's the syntax highlighting just helped me there since it wasn't purple. I knew I'd misspelled it. So the purpose of this is going to be to sort the table and then rebuild in the new order. So the last thing it does, well, we can do that right now. It's going to call rebuild table, right? So that's the last thing it's going to do. It just needs to call that function. That'll already rebuild it. It also needs to sort, but it's going to need to sort depending on the value. Let's go ahead and grab this one. And when would we want to sort by name? Well, we'd want to do that when call index equals 0. So let's just do that. If call index equals 0, then we'll go ahead and sort by this. There we go. Let's go again. Else if call index equals 1, we're going to want to sort on something different. So column 0 is name, column 1 is type. So we'd want to change this now to be type. And then last but not least would be age. And since this is the last possibility, we don't actually need an if. We'll just make it the generic catch-all else, which is a good thing to have. Bring this out a little bit, and we need one more closing brace there. That was just me doing bad copy-paste. There we go. That's better. And this time we want to sort by age. And we could do this by subtracting, but let's keep the pattern the same so that we see what the three things are here. So 0 is name, 1 is type, and then the last one is age. There would be other ways to do this as well. This is just a particular way to do it. If you know what a switch statement is, boy, that would be really useful right here, but I'm not going to do it because I don't want to add confusion. So what are we doing here? Sort array based on the index. And then rebuild the table. So now I can just call that function. I can say sort and rebuild table, and let's say initially we want to sort by age. That would be index 2. And there we go. It sorts by age, and the whole table is now sorted by that. Let's say I'd rather have it be 1. There we go. It's going to sort by that. Now where I'm headed with this is that I actually want the user to be able to choose what to sort by. And the way we'll do that is we'll just have them click on the title of the column, and whichever one they click on, we'll sort by that. This actually isn't too hard to do. You've seen all the building pieces for it again, so let's just make it happen here. Here is where we're creating the header. So remember, we make a new header row. And then for each column name, we're going to go through, create a header cell for that name, assign that name to the inner HTML, and then append it to the row. Now what I'd like to do is for each of these columns, I'd like to give it an on-click event so that when you click it, it sorts by that particular number. I have a function all ready to do that for me. So what I need to do here, let's go to new head cell and let's assign its on-click. You guys saw this already. We assign it a function. It doesn't need to take any parameters in our case because it's just going to be a function that's called right away. And the parameters going to it, you know, it could receive the mouse event if we wanted to deal with that, but we don't really care about the mouse event. What we do care about is what function it calls. It needs to recall sort and rebuild table, and it needs to pass in the index of this particular column, which would normally be I. But we're not in a for loop, we're in a for each loop, so we don't have an I. But hopefully you remember we can. We just add it to the list of parameters to the function that's taken by for each, and then you're allowed to do it. So when we click this, it's going to sort and rebuild the table based on its column name. Now, the last thing I want to do here is to switch this rec to rebuild table. I don't want it to be initially sorted. Let's see if it all works. Here's our page. If I click on, let's say, type, it does it. The mouse looks a little weird, but it does it. It's sorted by bird. Let's see, click on name. There we go, it's sorted by name. And look here, you can look down through all of this and see that it is truly rebuilding the table from scratch after it sorts the array. Well, that's something interesting. Why did 7 wind up down here? We'll have to look at that. That's a bit odd, isn't it? Flee down to here. So there we go. We're getting some pretty good results. I want to fix one thing real quick. Because this is just a TH cell, it doesn't automatically show that it's clickable. But there's something really easy we can do to fix that. We'd like to be able to modify the style so that it shows a different cursor when you hover over it. To do that, we say new head cell dot style. And style is going to be equal to an object that contains all of the key value pairs that were set in this object's CSS. It's actually pretty powerful. The particular key we want to modify is cursor. And we want to set it equal to the value pointer. This says when you're over this, show the pointer cursor, which is the cursor you see when you're over a link. And so now, when I go over it, it should be showing it. There it is. Now I see a pointer. And that says, please click me. And so it gives the user the idea that they can click on these things. Now there's one last weird thing going on here. When we sort by age, we just noticed that 7's winding up at the bottom here. I'm going to leave it to you guys to think about that. Why might that be sorted all the way down to the bottom? And I'll give you a big hint. It has to do with data types. I pointed out at the beginning of this whole thing that data types are stored underneath and behave differently depending on how they're explicitly defined. And when we looked at pet data, one of these things had a data type that was a bit odd. See if you can figure it out, and also see if you can figure out a way to fix it. How do we do things better in here to get it to sort the right way?